Welcome back to the playlist of linear algebra. Here I want to discuss the one example about the application of linear algebra. As you remember, we used linear algebra in which areas like economics, traffic flow. Right now I want to use it in chemistry. So we have an equation. Our task is to balance that chemical equation due to the limestone. Calcium carbonate neutralizes the acid trihydrogen in acid rain by the following unbalanced equation. So we have trihydrogen plus calcium carbonate is equal to water plus calcium plus carbon dioxide. So what do we have to do in order to apply linear algebra here? What does it mean, balance the chemical equation? Even though from the simple chemistry we can understand that, let's for example remember what did we do in chemistry class from high school or middle school, doesn't matter. So for example, on the left side we have how many oxygen? 1 and 3, so totally it's 4. What about here? 1 and 2, so it's 3. Our task is to balance two sides. So if on the left side is 4, then on the right side should be 3. But how do we have to do it? We have to have coefficients before the compounds. For example, it should be like this. Let's say 3, 2, and for example here is 2, I don't know. Actually it should be 3. No. Doesn't matter. So for this case, linear algebra also can support us. Let's assume that we can write their coefficients as variables x1, x2, x3, x4, and x5. But we have chemical elements: calcium, helium, carbon, and oxygen. But we have to use matrix, and inside of matrix we are going to have components using the chemical elements. For example, let's start with calcium. Second component is going to be carbon. Next one, let's say helium, and the next one is gonna be oxygen. So for the trihydrogen, what it's going to be? How many calcium do we have here? 0. How many carbon? 0. How many helium? 3. And how many oxygen is 1? Let's go to another one. So correspondingly it's 1, 1, 0, and 3. Water 0, 0, 2, 1. Calcium just only 1, others are zeros. One more compound, carbon dioxide. So let's write matrices instead of compounds using the coefficients as well. So it's like x1, So for the easier computation, or actually if we want to combine all those matrices to the one matrix, we have to move all those three matrices from the right side to the left side. We could write plus I, we could actually write minus x3, but we can also alternatively write 0, 0, minus 2, and minus 1. And on the right side is going to be 0 matrix. Looks like a homogeneous system. And so this is a vector equation of the chemical reaction. So let's create the following matrix. Okay, let me zoom a bit and let's work with row operations. So as you can see, the first component is 0. Let's make it as 1. For this purpose, we have to just change our rows as R4 and row 1. So let's see, what can we do more? Let's eliminate this tree to find basics, to find pivot positions. Three minus 3, 0. 0 minus 9, minus 9. Minus 2 plus 3, 1. 0. 0 minus 6, minus 6. Or is it the plus 6? Excuse me, it's actually plus 6 or just 6. What's the next step? Let's eliminate this minus 9. So it's gonna be R3 is R3 plus 9R2. So it's 0 here, minus 9 plus 9, 0, 1 plus 0, 1, 0 plus 0, 0, 6 minus 9, it's minus 3. Is everything correct until now? Let's move on. And also, we want to eliminate this. So the following row operations is going to be, let's make it like this. R4 is R4 minus R2. One minus one, 0. So it's 0 here. Minus 1, minus 0, minus 1, and 0 plus 1 is 1. So as you can see, we got pivot positions everywhere. Let's indicate these positions as x1, x2, x3, x4, but also x5 as well, but x5 is not pivot position. We call it as free variable, but what about others once it's basics? So let's find the values. So let's start with the last row. For example, it's minus x4 plus x5. We have to find the x4. Minus x4 is equal to minus x5. x4 is x5. Let's go to the third row. So it's x3 minus 3x5 is equal to 0. x3 is equal to 3x5. Let's go to the second row. x2 minus x5 is equal to 0. So x2 is equal to x5. And the first row, x1 plus 3x2 minus x3 minus 2x5 is equal to 0. So we know that x1 plus 3x2, we can write it like is 3x5 minus x3 is going to be just minus 3x5 and minus 2x5. Those guys are eliminated. So x1 minus 2x5. So x1 is just 2x5. Let's write the matrix for the x variable. There are 5 components. So x1 is 2x5, x2 is x5, x3 was 3x5, x4 was x5, and x5 is just free variable. Let's take out x5 from the matrix and let's see its corresponding coefficients. That's not our result, that's not our conclusion. So let's just imagine what if x5 is just 1. Let's put x5 as 1. So what do we get? We can just put them instead of x5, we can just put just 1 here. For example, 2 times 1 is just 2. So x1 is 2. What about this one? X2 is 1. For the x3 is 3 times 1 is 3. x4 is just 1 as well. And x5 is just 1. Let's go to our chemical equation. 2, 1, 3, 1, 1. Okay. and let's see, is it correct? Let's remove these coefficients. So we say that x1 is 2, second compound is 1, third compound is 3, another one is what was x4, 1, and carbon dioxide is going to be 1. Let's compare. So first of all, how many helium do we have on the left side? 2 and 3. We multiply them, it's going to be 6. Here we have only here helium, so it's 6. Let's write like this, 6 helium. Another one. How many oxygen do we have? So 2 times 1, so it's 2 on the left side plus this 3, so it's 5 on the left side. What about here? 3 times 1, 3, and this 1 times 2 oxygen, so it's also 5. Okay, let's go to the calcium. We have 1 calcium on the left side and 1 calcium on the right side, so 1 calcium, that's okay, and 1 more carbon. 1 carbon on the left side and 1 carbon on the right side. That's it. Thank you for your attention.